Hey guys, this is Coach Friday, and today we're going to be talking about Chapter 4.3, which is graphing linear, non-proportional relationships. In this chapter, the TEK that we're going to be looking at is 8.5b, which says represent linear, non-proportional situations with tables, graphs, and equations in the form of y equals mx plus b, where b is not equal to 0. A lot of these words you guys already know, which include linear, non-proportional. You guys know what a table looks like, a graph, an equation, and your slope-intercept form, which is y equals mx plus b. So the question that you need to be able to answer by the end of this lesson is, how can you graph a line using a slope and a y-intercept? So looking at this TEK and breaking it down just a little bit, the words that I want to look at is linear and non-proportional. First, the word linear. Okay, linear actually has the word line in it, and linear just simply means that it's a straight line. Straight line because the rate of change is constant. Non-proportional means that it does not go through the origin, and when we look at the equation, when it is in slope-intercept form, y equals mx plus b, that b is actually a number. It's not 0 anymore, like when we were looking at proportional relationships. So non-proportional means it does not go through the origin, and that b is something other than 0. Let's look more into our slope-intercept form. Remember, our equation is y is equal to mx plus b. Looking first at m is going to represent something that we've looked at last chapter, and that is our slope, constant rate of change, and our constant of proportionality. Now this formula, if I cover up that b, okay, and change the m with a k, that's exactly what our equation was last chapter. Y is equal to kx is the same thing as y is equal to mx. We just switched out k and m. So m is our slope. B, on the other hand, is going to be our initial value. Okay, it's also our y-intercept, and that just means wherever the line crosses the y-axis, that is our y-intercept. So that point is always going to be 0, comma, a number, and we might see that as in a table as well. So again, remember, our essential question is, how can you graph a line using the slope and y-intercept? So let's just write out the steps. The first step is we want to plot the y-intercept. Okay, so you guys are given an equation, and plotting the y-intercept is easy because it's going to be that plus or minus b from our equation. Step 2, we're going to use the slope to find the second point. And when we use the slope, we want to keep it as a fraction because we want to do rise over run to figure out the other points in that linear relationship function. Okay, and step 3, we have to draw a line through the points to connect all the points to show that it's continuous. Now that line also represents that there's lots of points that fall into that equation that make that statement true. Those are all solutions of those points, or of that line. So now let's look at a couple examples. Okay, the first example that we're going to look at is this graph right here. Okay, the equation that I'm giving you is y is equal to 1/2 x plus 1. Okay, right away we know that this is in slope-intercept form, which is y is equal to mx plus b. So if I'm looking at my b, which is my y-intercept, okay, that b is positive 1. So y-intercept is where it crosses over on the y-axis, so I'm going to put a point on positive 1. Step 2, I'm going to use the slope to find the second point. Now my slope, which is my m, is already written as a fraction, so that makes it easier on me. Remember, the top number represents my rise, which is the change in the y values. My bottom number represents the run, which is the change in the x values. So since it's positive 1, I know I'm going up 1, and positive 2 represents for the run to the right 2. Okay, so from my y-intercept, I'm going up 1 over 2 and putting a point there. Up 1 over 2. Up 1 over 2. Okay, I could also go start from my y-intercept and just go backwards, so I could go down 1 to the left 2. Down 1 to the left 2, and continue making points. My third step is to draw a line and connecting these points. Remember, when you draw that line, you have arrows on both sides of that line showing that it's continuous. Go ahead and take a second to do this second example of graphing a linear equation, and push play in a couple of minutes when you're done. Looking at this equation, our first step is to plot the y-intercept. My y-intercept, since it's already in slope-intercept form, is positive 4. From there, I'm going to look at my m, which is negative 3. Now, I want to have that written as a fraction just because that's easier for me to plot the other points based off of the slope and rise over run. So whenever I have a whole number as the slope, I can always put it over 1 to keep that same value. So my slope here is negative 3 over 1, which means I'm going down 3 and to the right 1. Since my slope is negative, I know after I plot all my points, my graph should be a negative slope, which means it goes down from left to right. So, since I'm going down 3, 1, 2, 3, and to the right 1, I'm going to plot my second point there. I'm going to continue down 3, to the right 1, and plot my third point there. I'm going to connect my dots, put arrows on the end to show it's continuous, and also double check my work that the y-intercept is 4 and that my slope is negative, so from left to right it is going down. Now we're going to look at a real-world situation on when we would have to actually plot equations like this. So in this problem it says a public pool charges a membership fee and a fee for each visit. The equation y equals 3x plus 50 represents the cost y for x visit. Right away I would look at my graph. I would label my y and my x-axis based off of the information provided in the problem. So, again, it said my cost is y, so I labeled my y-axis cost, and x is visits, so my x-axis is visits. The question that it's asking me is, after locating the y-intercept on the coordinate plane shown, can you move up 3 grid lines and right 1 grid line to find a second point and explain why? So first, I have to locate that y-intercept. Now, I already have been given the actual equation, or in slope-intercept form. So, y equals mx plus b, and I remember that my b part really represents my y-intercept. So in this equation, the plus 50 is my y-intercept. So I'm going to go ahead and plot that point. Now, if I were to plot the other points on this graph, I would actually use the m, which is my slope, and this is labeled in this problem with 3. So if my m, or my slope, is 3, I want to put that into a fraction form because that means that it's going to be easier on me when I do rise over run. So I'm going to put that whole number over 1. Okay, and this just means I'm going up 3 and to the right 1. So from this point, I'm going to go up 3, 1, 2, 3, and to the right 1. Up 3, to the right 1. Up 3, and to the right 1. I'm going to connect my points and put an arrow on the end. Now this time I only have one arrow because this is a real world situation. I'm not going to have negative visits or a negative amount of money if I don't go to the pool. So when it's a real world situation, all of our problems are going to be in quadrant 1. It's not going to be in quadrant 2 or quadrant 3 or quadrant 4. Everything's going to be in quadrant 1. So now that I located my y-intercept and I already plotted my other points, it asks me, can you move up 3 grid lines and right 1 grid line to find the second point? And that's exactly what we did. We went up 3 grid lines and right 1 to find that second point. Now the values should be the same. Remember, the grid lines aren't going up by 1 unit, they're actually going up by 25 units here. So I need to make sure that my answer is still reasonable based off of the equation. So if I'm looking at my y, which is my rise, I went from 50 to about 125. Okay, which means I went up 75. if I look at my x values, so I went up 3, which represents 75, so plus 75, and I went to the right 1 unit, which was between 0 and 25, so that was 25. Now if I still take rise over run, 75 over 25, if I simplify that, it's going to simplify to 3 over 1, which ends up being the same exact slope that I used over here, which is in my equation. So yes, you can move up 3 grid lines and right 1 grid line to find that second point. Now question B, it says graph the equation, which we already have, then interpret the slope and the y-intercept. So if I'm looking at my equation that's already been graphed, my x represents the visit still, and the y represents the cost. So if I need to interpret the slope first, okay, my slope is 3. In my equations, if I actually use words to describe this, that means y is the cost. So the total cost is equal to $3 per visit plus the $50 membership fee. So this 3 is going to represent the $3 per pool visit. Now if we were to interpret the y-intercept, remember our y-intercept is where it crosses over the y-axis. So this point is actually 0, 50. In our ordered pair, x comes before y. So if this represents x, x represents visits. So at 0 visits, y is going to be my total cost. So we have to pay $50. That's my total cost. Okay, so my B is $50 just from the equation. And to interpret that, that's the membership fee. And since I have to pay that, even though I've never visited before, okay, that's just a one-time fee. That's my initial value. 0 visits, I still have to pay that $50 before I can go to the pool and actually visit more. So now, part C says how many visits to the pool can a member get for $200? $200, if I look at my x and my y values on my axes, okay, $200 is going to represent the cost, which means y is going to be $200. So using my equation, y is equal to 3x plus 50, I'm going to substitute 200 in for y. And that's saying that the total cost that I have, or the total amount of money, I need to figure out how many visits I can take after spending my $50 one-time fee for the membership. So from here, this is a two-step equation. So I need to isolate the variable. So by getting the variable by itself, I'm going to subtract 50 on both sides. So now I have 150 is equal to 3x. And then this is a one-step equation. Right now I'm multiplying 3 times x. So to do the inverse operation or undo this, I would divide by 3. So 150 divided by 3 is going to be 50. And since x is equal to 50, that would represent 50 visits. So, if you remember, and you had $200, you would have to pay the $50 membership fee, and then you would be able to go for 50 visits to the pool under your $200 limit. Now this is sort of what the question would look like on the star. However, this TEK didn't change from last year. A lot of your new TEKs are coming down from algebra. However, this TEK is very similar to what we've seen in the past. So looking at the questions that were identified by this TEK on star last year, here's 2 questions. This first question says, the graph models the value of a machine over a 10-year period. Value of the machine, value, and age of the machine. It says, which equation best represents the relationship between x, the age of the machine in years, and y, the value of the machine in dollars, over this 10-year period. So right away, all my answer choices are in slope-intercept form, so I need to be able to write an equation based off of this graph. So even if I cover up my answer choices, I should be able to do this without looking at my answer choices. So to write an equation from a slope, okay, I'm actually working backward. if I was to graph an equation, okay, the first thing I would do is plot the y-intercept. So I'm looking for my y-intercept here, and that again is where it crosses over the y-axis. So my y-intercept is 8. However, if I look very closely at the description, it says value is in thousands of dollars. So technically it's not 8, it's actually 8,000. Okay, now from there I need to figure out what the slope is to make my equation in slope-intercept form. Remember, we want to write our equation in y equal mx plus b. So we have the b done already. Now we're trying to find the slope. So I'm going to choose another point that intersects the grid lines perfectly. And from the furthest left point, I'm going to do rise over run to get to the next one. So from my furthest left point, I'm going to go down 1 and to the right 2. Now if I look, I'm going down 1, so that's going to be negative 1 all over 2. So negative 1/2. Is that correct? No, it's actually not, because remember our values and our y value. Okay, I'm going down 1 unit, but remember it's in thousands of dollars, so this should be down 1,000 over 2. So when I simplify this slope, I'm going down, if I simplify this by cutting both in half, it's negative 500 over 1. So my slope here is negative 500 over 1, my y-intercept is 8,000. So if I were to write an equation from what I already have found, my equation is going to be y is equal to m, which is negative 500 over 1x, plus my b, which is 8,000. So now let's uncover and figure out what is actually the correct answer. So if I look at A, this is y is equal to negative 0.002x plus 2,050. That's incorrect. If I look at B, y is equal to negative 500x plus 8,000. So 8,000 would be my y-intercept, negative 50 would be my slope. That's exactly what I have, but I'm still going to check all the answers before I choose it. Letter C, y is equal to 500x plus 8,000. So that the only difference between B and C is a negative. If I check, this line is going down from left to right, so I know it has to be a negative slope. So C is definitely out. D is y is equal to 0.002x plus 2,500. That's incorrect because I know that the y-intercept is not that, it's 8,000. So the only answer that would be correct here after doing the work, without even looking at the answers, would be B, which is negative 500x plus 8,000. Go ahead and do number 22 by yourself from the 2014 STAR. Pause the video and see if you can figure it out by yourself. Okay, number 22. Okay, it gives us the equation, and we want to represent show which graph best represents this equation. So if I look at the equation, y is equal to 1.4x plus 2, right away I would have to graph the y-intercept. That's the first step. So my y-intercept is positive 2. So if I look at my answer choices, okay, I am going to look where it crosses over the y-axis. So if I look at F, it crosses over the y-axis at the origin. That's incorrect because this problem would have plus 0 as the B if it was the correct answer. So F is out. If I look at H, H again crosses over the origin, so H is out. Remember what we're looking for. We're looking for when the line crosses the y-axis at positive 2. So going down to G, I'm looking at the line, it crosses over at positive 2. So G is a possibility for an answer. If I look at J, I notice that it crosses over at positive 1. So this equation would be y is equal to mx plus 1, which doesn't match up with the equation that was given. So my only answer choice here would be graph G. So let's go back to the essential question that you guys are supposed to know and how to answer before this end of this lesson. So remember, the essential question was, how do we graph a line using the slope and the y-intercept? Remember, there's 3 steps. The first step is plot the y-intercept, which is going to be 0, then that number. And remember, in our equation, the y-intercept is the b. After I plot the y-intercept, I'm going to use the slope, and hopefully it's written as a fraction. If not, write it as a fraction to find the second point. And we're going to use rise over run. And the last step is we're going to draw a line through the points to show that it's continuous, and to show that that line, there's lots of points that fit into that function that would make that function true. So hopefully, before you began, you might not have known the essential question and how to answer that, but hopefully by the end of this lesson, you are able to identify how to graph a line using that slope and the y-intercept from an equation. I'll see you guys in class tomorrow. Have a great night.